Welcome to this third part of this Arduino workshop. In this workshop I'm going to tell you all about the Arduino, programming it with sketches and all the different help that is available in order to do so. So in order to start, we have 1, 2, 3D circuits. I'm logged in. I can start a new breadboard. Inside this new circuit I'm going to put a Arduino. Put it here, and I'm going to show you to this show this site arduino.cc. So because in this workshop you're going to actually build something with an Arduino. So this Arduino, if all is well, you would have an Arduino available at the moment, and you need to download your Arduino IDE from this site. You can press download and you can go to Windows Installer or the Mac or Linux. I'm on a Windows machine, so I pressed Windows, and inside this package that's downloaded there's the integrated development environment. That's an IDE. It helps you to program the Arduino, and there will be drivers inside that install on a Windows machine, so you can talk with your Arduino and program it. So just install everything, and then if you've done so, you would have an Arduino inside the menu. So I already did a lot with this stuff, but if you've opened it for the first time, you would have the bare minimum. So this one, you would have this. So if you see here, this is the bare minimum. It needs two functions, one called setup, one called loop. The setup is just meant for initializing stuff, and the loop is just doing all the work. So it keeps looping. All the code that's inside here will be run indefinitely. Okay, to check, I suggest you connect your Arduino at the moment to your computer and check if you can talk with your Arduino. So in my case, my Arduino is connected and is connected to COM port 3. You could have another COM port, it doesn't really matter. You need to find out your COM port in order to talk with your Arduino. I can just check if I have any errors in this script or this sketch. Compiling sketch, it says, and I can upload it, and the Arduino Uno will be blinking, and at the moment I see that it was successful. So I programmed my Arduino to do nothing really boring, but it just is needed to check the connections with your Arduino. So if you've done that, then we can take the next step. If you want to build something for an Arduino, you should not start from scratch in a way that you start writing code starting from line 1. You should always look for examples or other material on the web. Under learning examples, there are a lot of examples here that teach you how to do something. So if, for instance, I just want to turn an LED on or off, there's a simple basic script, blink. I can press that, and there's a whole description about how you can do that. This is a simplified way of using an LED and a resistor to have a blinking LED. This is the schematic of it. This is the Arduino. You can see all the ports here, and here's the resistor here and the LED. This is the symbol for the LED, and it goes back to ground. So the code, it also is explained in a lot of detail what is it doing. So I'm going to get this script, I'm going to select it, Control C, Command C on a Mac, Control C on a PC, and I'm going to use this script in my simulation environment. So I'm going to click here on, I'm going to get rid of the Components tab. I'm going to go to Code Editor. It just so happens that this code already is blinking something, but I just delete it and put this new code inside. It does exactly the same thing. I just want to show you how you can program your Arduino with code from the web or from the Arduino side. In this case, I can just upload and run, and successfully compiled, and it's running. I can see that because here is the LED blinking. Okay, this is running. So you should now try this as well. So go to, once your Arduino is, you have a connection to the Arduino. If you don't have a connection with the Arduino, ask the workshop leader. He should know how to do this. And then you can go to examples, basics, and just blink. So you can close the other script, the bare minimum. We will not use it. And here's the blink script. So what you can do is just press this compile. It compiles, no errors, and you can press upload. And the Arduino Uno will be blinking very fast in the beginning, and that means it's being programmed. And then, if all is well, you should have a steady blinking LED on your Arduino. So if this happens to you, well, congratulations. This is the sort of, it's like a hello world program for the Arduino. Once you have an LED blinking, you've got a lot of, you tested the communication with the Arduino, plus you showed that you can program, or at least copy paste and program, and it works. So this is a really easy example, but I'm just showing it to you so you know how you can proceed. If you want one blinking LED, you just look it up on the web. Inside the Arduino website, you'll find a lot of hints and tips regarding how to do that. This is how I do my projects. If I'm doing something with an Arduino, I just find bits and pieces on the web and I just combine them to a working piece. So, what do we have more to say about the examples? I'm not gonna show you the blinking LED. It's too easy. The bare minimum, we won't do that. We will do analog and digital read serial, and we will do the fade at the end. So I'm gonna walk you through these three scripts, and they'll tell you about digital read, analog read, and fade. That's a very powerful way of using only a digital pin to simulate a sort of an analog signal. But I'll explain that in detail when I got to fade. So first I'm going to do digital read serial. Digital read serial, what do we need? We need this circuit. So there's a push button here, a resistor there, and some wires. So let's build it. You can go to the simulation environment. First start it in the simulation environment. If it works there, then only build it on the Arduino itself. So I'm just gonna open the components, and we have a resistor, put it here, and we have a push button somewhere. Here we have the push button, click. The push button is a it's not a normal button as you would expect, but it'll be clear once you do it, I hope. We're gonna look at this push button will be situated in the middle of the breadboard, and in order to do that, I'm just gonna pick it up and put it there. The resistor we're gonna pick it up with my left mouse button, press R to rotate and put it so it snaps into place. Okay. What else do we need? We need a 0. This is a digital pin. It's at 2. So we need to go to number 2. 2 will be going there. Okay. And this +5 and ground will be these two rails. So let's do that. +5 and ground. There we go. From there, I can see there's a +5 going up to the first pin. So this it doesn't really show well. This is the +5 rail and goes up. and the minus rail. Oh, I did it the wrong way around. I should also color code. This is the best way to. So +5 is this one here, and this one here is the ground. Just mark it black. So now it's a lot easier to distinguish between plus and minus if you use colors on your wires. Your actual wires should also resemble these colors, because if you're working with voltage, plus voltage and minus voltage, always use red and black cables. So if I have the +5, it's on top. This is strange. It's a different. Yeah, this doesn't work out, because here the +5 is this top part, and in our case that's the minus, but it doesn't matter. We just need to connect the left one to the plus. So we can need the left one to the plus. That's one. And we need at the end of the resistor to the minus. End of the resistor to the minus. Okay, I think I have it connected at the moment, and this is not really needed. It's nice to connect the other rail as well, but it's not needed for this example. So, okay, do we have the code? We need the code. So I'm going to scroll down past the schematic and an explanation of the code, and just put it, that whole thing, Control C, Command C on a Mac, put it here, Control A, Control V. So I just deleted everything and put the other code inside. So now I'm gonna press upload and run. So it's successfully compiled and it uploaded. What does it do actually? Well, it says so right here. Reads a digital input on pin 2. Yes, we saw that. That's this pin. Digital input. Digital input. Digital means either a 0 or 1. So it reads a 0 or a 1. And what does it do? Prints the result to the serial monitor. Well, that's a thing I didn't talk about yet. The serial monitor is a stuff that's here on the right. So if you've got your code editor open, on the right there's a serial monitor. You can click it to make it active. So it's sending out zeros. The Arduino is in simulation sending over the serial port, over this port here, it's sending zeros. And if I now just make it a bit smaller so I can press the button, if I now press it, there's a 1. If I release it, there's a 0. There's a 1 and a 0. So in this little schematic, what it does, the code is, it starts a serial connection in the setup. The pin mode of the push button is set to input, so the push button is just a number and it's set to 2. So actually it says pin mode number 2. So pin number 2, what is it? An input or an output? It's set as input. And then inside the loop there's a button state. It's also a number, and what number is it? It's digital read push button. So it reads the digital value of what enters here inside this pin. Is it a 0 or a 1? So this button state is a 0 or a 1. And then it prints out over the serial communication line, it prints out serial print line button state. And this button state then would be 0 or 1. So depending on if we press the button or not, it would send a 0 or a 1. I suggest you look into how this push button works, because it's I can show you. If you see the push button Arduino, and I'm looking at images, and I'm going to show you here the push buttons. Here we go. I'm looking at one particular example where you can easily see how it is configured inside. Yeah, this is the circuit die. This is the push button here. So these two are connected, and you press the button. Everything is connected in an H form. So I hope this explains a little bit about how this push button works. In the beginning it's a bit confusing, but because it's not a normal button. These two, this one and this one, are connected whether I press it or not. And this one is also connected whether I press it or not. When I press the button, everything is connected with each other. So this is how you can use this button inside a breadboard to switch between a low, because if I don't press it, this here enters here and goes to the ground here. So this voltage here would be 0 because there's no current flowing. So it's not it reads a 0, and if I would press it, this would be the circuit here. From plus it would go to the input pin, and that would read a 1. Okay, just you can also read about it on the site here on the script. We'll just continue to the next example, because the example here, we're going to examples, and we can go to digital read serial. We can go to analog read serial, because a digital signal you can read either 1 or 0, but you can also read analog signals. And analog signals you can build this. This is just a very simple circuit using, I'm gonna press Control equal. I can zoom in and you see plus 5 volts ground, and it's connected to analog 0. So I can scroll down as well to see, zoom out a bit. This is the connection, the schematic. Here we have the schematic of the connections, and it's explained what is being done. And I can just copy this, Control C. I can go here. I can actually make a new breadboard. So I can start with a clean slate. I can put the components. You can also remove the components of the last one. Okay, let's just close the components. Actually, I shouldn't have done that, because I need my little here potentiometer. Here we go. Okay, I can open up the code editor and Control A, Control A, Control V. So analog read serial. So it's not digital read and then put something on the serial port. No, it's analog read, and analog is a value between a digital value between 0 and 1024. It's actually a value between a voltage value between 0 and 5 volts. So what we need here is to check this, reads the analog input 0, 1. So analog, that's the other side, analog 0, 1, we can put here in the, oh, it doesn't work like that. Need to put it a bit up. Okay, analog 0, put it here. We need the plus 5 on one side, and we need the ground. These are all interconnected, by the way. Ground is ground. And then we can upload and run. And we can check the serial monitor, and we can see 1023. Okay, if we now turn this knob, you can see the value changing all the way to 0. And we can change it back all the way to 1023. Combined with the 0, that's 1024, the biggest. And if we just stop the simulation, this is something you can do in simulation. Void setup serial begin. This starts the serial communication. at 9,600 baud, that means bits per second. You need that in the setup. And then there's a sensor value, that's an integer, that's just a value that holds what it reads on the analog A0 port. Analog read, it reads the value there, and this is a value apparently between 0 and 1024. That's 10 bits value. It's being read inside the analog read, and it just prints it over the serial port, print line, and it puts a new line at every new value it prints. So it prints the sensor value. The delay here is just for stability reasons. It's needed. So this is how you can do that, and this is how you can put an analog signal and just read the value of this analog signal. So you can now use this knowledge inside your project. This script you can just use, and if you run the start simulation, you can build something that, depending upon this knob here, something else changes as well. For instance, a motor will be spinning faster or slower. You can do that. This is my step up to the next section of the examples, because I did the bare minimum, the blink, digital read, analog read. I'm not going to do read analog voltage. I'm going to do fade, and fade demonstrates the use of an analog output to fade an LED. Okay, the Arduino is not able to send out analog signals. It cannot do that. It uses pulse width modulation, and I'm going to show you how that works, because this is one of the most nicest things I came across when working with an Arduino. When I found out that how you can do an analog write. So for instance, if you want to write out a voltage value of 3 volts, for instance, how you can do that with the Arduino is doing something that is that is called pulse width modulation. I'm just gonna talk you through it. Okay, what we can do here is, of course, we have how we should connect it in the schematic. It's just an LED and of course a resistor, and inside the schematic here, resistor, LED, and that's it. So I want to, what does it do? The script will be fading the LED on pin 9, and it just will show an LED going bright and then dim and going brighter and then dim, and it keeps repeating like that. So there's a lot of code here. Also the pin mode, this setup here as well, these integer initializations, and inside the setup there's a pin mode set, and then the loop starts analog write an LED with a certain brightness value. This might seem difficult, but you can just use it. Don't think too hard about how this works. If you want to set something, if you want to fade something like this, you can just use this code. I will explain to you how this pulse width modulation works. I can show it to you in the simulation. So what I do here is I'm gonna open this up, Control C, go to my circuit. I'm gonna make a new breadboard. And components. Okay, I need a resistor, I need a LED, and I need the Arduino. So close the components tab, click the zoom. Okay, put the resistor in there, press R to rotate it, put it somewhere. And we have this LED, just put it somewhere in the breadboard. Close this push button, and and just check how it's being connected. I can also work off the schematic. It says here D9. It's a pulse width modulation pin. Yes, I can tell more about that as well. If you see here, digital, and it says between brackets, between PWM, it's this tilde sign. And this 9, 10, and 11 are the digital pins that also function as a pulse width. You can use these pins for pulse width modulation. And I'm gonna show you what that is. So I need to use pin D9 through the resistor, through the LED, and then to the ground. So pin 9 through the resistor, through the LED, and then to the ground. So this is the cathode, cathode is negative. So this left side here, the flat side, is the negative side. And then to the negative rail here. And now I also need to connect the ground here. So now it's properly connected. Ground, resistor in the terminal 9. Yes, here we go. I could have also done this. Let's do that. I could have also done this straight up here. It's also possible. Okay, and just to make it clear, that is the positive. That's the ground, the ground wire. Okay, so zoom out, and we're gonna go to the code editor, and this is the default script, the default sketch. I'm gonna delete it. I'm going to go to my Arduino fade code. Here it is. Everything from top to bottom, put it inside this script here for the Arduino Uno. Upload and run. Let's do that. And if all is well, you should see it brighten and dim, brighten and dim. So what is happening here? Pulse width modulation, it tries to simulate an analog voltage by sending differently sized pulses towards the LED. And in order for me to show you how this works, I can tell you how you can put a oscilloscope here. And an oscilloscope is a nice device because now you can see in time what the voltage is doing. So here you see all these pulses here. I'm going to press the oscilloscope, and I'm gonna get auto scale out of the way, and what shall we do here? 0.2 volts. Here we go. Time per division 10, 1. Here we go. This is a nice view of the pulse width modulation at work. What you see here is this is a cycle. So this is a cycle. You see a repeating pattern here. This top, and then the 1 and the 0, and then the 1 and the 0, that's a cycle. So it all happens here. This width here, that's because it's called pulse width. It's a pulse, and the width of the pulse, so the time it takes for it to go up and then down, that determines the brightness. So this is how it's simulated. It's because there is this LED will then, for instance, if we would have a pulse width of 50%, I can do that with my code editor. I can set it to I can comment out the brightness here. I need to stop the simulation. So I need to comment brightness is brightness plus fade amount. I'm gonna comment it out so it doesn't do anything anymore. It's comment now. And what I do here is brightness let's put it at, it's a value between 0 and 255. So let's put it at 128. Let's put it there. So the brightness, I change the value to 128 and it's not changing. So it'll keep pulsing the LED with a 50% pulse width, and that's this brightness. So if I would now change that to, for instance, half of 128, that's 64. I would upload and run. You would see the pulse width is a quarter of the whole cycle here. So it would only be bright quarter of the full brightness. And the full brightness would then be 255. Upload and run. So now, if all is well, you would just have a continuous line. So there would be no zeros inside. So this is the way you can use a digital pin to simulate an analog output. It is as if, in this case, there would be 5 volts on the LED, and then we would change it back to 128. It will be 2.5 volts simulated. So it's half as dim as the full brightness of the LED. You can also go all the way back to 0. Upload and run. As you see here now, it's on 0, so it's not blinking anything. So this is how you can use pulse width modulation. You can use this for motors as well, and this is the last bit. You're almost there. I'm gonna put a DC motor in there because this is something you will use in your projects because you need to move stuff, right? Okay, well, this is a way you can move stuff. Is here. It has a plus and a minus. Let me do it like that. Okay, change. This can be here. This can be here, and then this can also be here. Okay, let's see how that works. I did something wrong. Okay, let's redo that. Undo. Okay, start simulation. It's on 0. I was still on 0. Okay, I also make mistakes. Okay, let's just put this at its default 0 and then uncomment the comment. So make it the brightness change again every time it starts the loop. Upload and run. Here we have it. Okay, let's put the motor inside. Again, the DC motor. Let's put this one here and this one there. Your layout can vary. I just want to make it work. Here we go. See? This is also a way to have a DC motor spin up and have a certain rotational speed. You can use pulse width modulation to pulse these motors to make them go faster or quicker just with a digital output port. You're going to use this inside your projects a lot. So this is a godsend that we have pulse width modulation on these pins, because these motors here, they cannot be operated. Most DC motors have one operational voltage, and that's 5 volts, and that's full speed. So if you want to change that, you with an Arduino, you can use pulse width modulation to control the rotational speed. It's like this. Okay, we covered a lot of ground. with all these experiments we're doing here, you can learn by doing. And I've talked you through most examples here inside the example section. And these are just the basics, but you can go, yeah, there's a lot of stuff you can do with an Arduino. There's all these examples here. You can just first simulate inside a safe environment of 1 to 3D circuits. And if it is running okay, you can then check out the real stuff. So you can build it using an Arduino IDE and then just make it, create it, do it. Just do it. Nike was right. Okay, I hope you enjoyed this workshop, and see you later.